start recording and replay the video. Alright, hello, this is the final lecture for waves and we'll be talking about electromagnetic spectrum. Now before we start, please click the Kurzgesagt video in the link, the first video, watch it first, then come back again because it will help you visualize the properties and memorize them better. So this part of the topic is a bit of a memory work, okay? So we're going to start off by talking about electromagnetic spectrum, which in and of itself is a range or a spread, okay? But it's also part of the spectrum light is part of the spectrum. So the electromagnetic spectrum consists of both electric field and magnetic fields, okay? And they're oscillating 90 degrees to each other. So say the electric field is oscillating up and down, but the magnetic field is also oscillating left and right, okay? And to simplify things, I'm going to give the electric field a symbol, E field, and the magnetic field a symbol, B field. Why B? You wait lah, when we reach A2, I'll talk about that. Okay, so magnetic field is B. So you have electric field and magnetic field traveling or oscillating at 90 degrees to each other. Okay, so they're oscillating 90 degrees to each other, and also at the same time, they are perpendicular to the direction of the electromagnetic radiation. So because of this, our beautiful wave is a transverse wave lah. Alright. Okay, as I was saying, electromagnetic radiation is a transverse wave. Both fields are oscillating perpendicular to the direction where the energy is being transferred. Alright. The second property would be electromagnetic radiation travels at the speed of light. Or rather, it travels is the fastest known speed. According to Einstein's theory of relativity, nothing can be faster than 3 times 10 to the power of 8. Okay, and it's a constant in vacuum. We also know that it can travel not just in vacuum, but also in other mediums as well. And the light tend to slow down in other medium. If you remember this thing called refraction from your AGs or from your SPM, whoever you are watching this video. Alright, and number 4, another property about electromagnetic spectrum, okay, is that it can be polarized. Now the thing about polarizing, right, is that they removed it temporarily from the A-level syllabus. So it's not here from 2016 to 2022. Lols, this is called flip-flop lah, huh? So if you're interested about what polarizing is, because I'm not going to waste your time to look at this, there will be a link down below, a quick demonstration about Polaroids and polarizing. Basically, it's the technology that we use to filter out some of the light while still allowing for visibility. Sunglasses, all right? And number 5, which is the most interesting thing, is that it can carry energy without having mass. So weird, right? If you think about energy, so you don't need a medium because the particles are not necessary. So no medium is needed. Okay, and we'll talk more about this in A2, about how light actually behaves or electromagnetic waves behave in quantum physics. Coming soon. Okay, so when we talk about a spectrum, we expect like a range. So as you can see here, there is a huge range and it goes from gamma ray all the way to radio wave, and memorize the spectrum. Not just the order, but you also need to memorize the frequency range and the wavelength range. And that part, I'm just going to leave it to you to figure out how. Repetition is memory, right? Okay, so if you notice, right, visible light is actually just a very thin band, meaning our eyes can detect electromagnetic waves, but only in a small range. Above visible light are all dangerous electromagnetic spectrum, starting with gamma rays. The higher the frequency, the more damaging it is to our bodies. So gamma rays have the largest frequency, and as we all know, gamma is radioactive, okay, and it has really short wavelength, because if you have a large F, you will need a small lambda because your V is constant. Okay, So, and you will notice that there's certain overlapping, like between X-ray and gamma rays, and this is generally to be expected. X-rays are also, as you know, ionizing and dangerous. When we say dangerous, means the ray is energetic enough or have a large enough frequency to steal electrons from your body, break the bonds, causing cancer. This is the same for ultraviolet, fondly known as skin cancer, or a deadly laser. Okay, you know, the sun is a deadly laser. So right now, these are all the ranges that you should know. Okay, and visible light is a really tiny band that we can detect. So closer to the upwards visible light, you get ultraviolet. Closer down to red, you get infrared. Okay, so purple light and blue light has a higher frequency and higher energy than red light. Okay, follow the order of your rainbow. Of course, towards the bottom, we have a bunch and a large chunk of radio wave. This one we'll learn more in A2. Okay, but they're all considered radio wave, just for a different function. Okay, and between that would be microwave. So this range of frequency and range of wavelengths has to be memorized or known. Generally, I'll show you a few questions and you can try more in your task 1.3 and task 2.2. Okay, so I just pick a few lah, right? So generally focus on the prefix because the prefix will tell you roughly what it is. I'm not really concerned about the answer. So look at me rubbing off the stuff so we can look at the question. Okay, so let's look at ON14, paper 1-1 first. Which statement about the electromagnetic radiation is correct? So this one is all about wavelength. We're just going to look at the prefix. So high energy gamma 10 to the negative 9. No law, negative 9 is about X-ray. So A is wrong. Okay, this is X-ray. And then 10 to the negative 8 is UV. Negative 8 is, UV, possible. I'm double check mark there. Okay, wavelength of negative 7 is infrared. So if you look at that, no, infrared is still above visible light. Okay, so that would be UV. That would be wrong. And light waves is around negative 6. You could say 9 times 10 to the power negative 7. And negative 6 is quite near leh. Well, yeah, but we choose the most accurate answer. Okay. Next question, this is from May, June 18. Which region of the electromagnetic spectrum includes waves with frequency 10 to the power of 7 megahertz? So this kind of memory work, right? It's like you know, you know, you don't know, you don't know. No? Okay, can't be helped. All right, so next part. What can be deduced from a table of wavelength of waves in the... Okay, so I'm listing down the spectrum and I've hidden my face so you can see the spectrum. We have gamma all the way to radio wave, and as we travel down the spectrum, the energy will drop, the waves beneath are safer, frequency drop, wavelength drop. So from here you can compare. Green light obviously cannot have a shorter wavelength. Red light cannot have a shorter wavelength than green light traveling down. And radio must have a longest wavelength. So in the end, what you have is X. The wavelength range of X-ray is less than that of radio waves. So now try task 1.3 and chapter 14 is over. Okay, I will do a recap later when I see you on Monday. All right, but I feel that you should also try more past papers if you have the time. If not, you can keep it to a bit later, but try not to accumulate your past papers and then look at it a week before your exam lah. That is not good. All right, so I'm just going to point out a few interesting questions that you should try. Even if you don't have time, just a few, not many. Okay, I would try this wheel question, the bicycle gear question. This one is in page 15, May, June 17. Okay, page 15, try this. This one is a bit interesting or different. All right, and this page has pretty interesting stuff. ON16, paper 1-1. Okay, so try those. And of course, finish up the structure because there you can refer to the mark scheme and learn how to write your answers. Okay, if there's anything you want me to look at or pay attention to, create a new page inside week 1 folder or week 1 section, and then I'll be able to notice it. Okay, so maybe you need to see me again. So I will see you in the next chapter or Monday. That's it for now. Have a good weekend. Bye bye.